In this week's lab, you're going to be looking at a variety of reactions, some of which you've seen before. This time we're going to try and put the reactions into balanced equations and to determine what type of reaction they are. So when you're looking at the types of reactions, you're going to want to pay attention to a few things. It's important to understand how many reactants and how many products you have, because if you have a decomposition or a synthesis reaction, there will only be one of those things. You also want to pay attention to, are any of the reactants or products acids or salts or elements, because that will also help you decide which type of reaction is going on. Your procedures ask you to make several observations, and so you're going to want to make sure that you make observations that are relevant in the chemical sense. We are looking for things that are going to help us identify if there are new compounds or elements being formed. So pay attention to colors and precipitation. Precipitation means that there is a solid being formed, and it may come in the form of just cloudiness within the liquid, or it may be a very obvious solid that is forming. You may also see bubbles, which is an indication of a gas being formed, and you may notice the test tube getting hot or very cold. That's an indication of some kind of an energy change. And finally, there will be one experiment in which you'll be paying attention to the flame. And again, with the flame, you're going to be paying attention to the color of the flame. Make sure to note all of these things in your notebook as you proceed.
For this week's lab, you will receive all of your materials in a basket, and you will also receive a lighter. The materials may be labeled on the top or on the side. In your drawer, you have a test tube rack with several small test tubes and one medium-sized test tube. You will use this to perform your experiments. Most of the experiments ask you to put 3 milliliters of a solution into the test tube. It is not necessary to measure out 3 milliliters. All of our experiments are qualitative, and this is about what 3 milliliters looks like. You'll notice it's about 1/3 full. If you're a little over or a little under, this won't affect your experiment at all. If you are part of the first class, you will need to leave enough of the solution in the container for the second class to repeat the experiment. You may have observed the first experiment earlier in the semester as we were reacting a strip of magnesium with oxygen in the air. For each of your experiments, consider how many reactants there are. In most cases, this will be obvious, but in this case, one of the reactants, oxygen, is in the air around us, so we have to remember that this actually has 2 reactants. Also pay attention to whether or not your reactants or products may contain pure elements. Make sure you observe your materials ahead of time. Use your crucible tongs so that you do not burn yourself, and perform this over a watch glass and also over a glass tile, so that you do not cause damage to the tabletops. Using your lighter, simply light the end and avoid looking at the flame once it begins. You do not need to hold the magnesium in the flame of the lighter once it ignites. Be sure to pay attention to the residue afterwards and record those observations as well.
All right, so in our second experiment, we're going to be reacting zinc and copper 2 sulfate. Your container of zinc will have multiple pieces. Please only put one in because you're going to need to save one for later. And if there's a class after you, they may need some pieces as well. Remember that you need about 3 milliliters of the copper 2 sulfate, but it doesn't need to be exact. So 1/4 to 1/3 full in your test tube is fine. With this reaction, you might not notice anything happening right away. Pay close attention to what's happening at the surface of the zinc, and come back to it later to make further observations. For this experiment, part C, you're going to test 3 different metals in hydrochloric acid. You may want to have 3 separate test tubes filled with the hydrochloric acid. Remember, about 1/4 to 1/3 full. Take the magnesium and put it in the hydrochloric acid. Take note of any reactions that happen, and then test also the zinc and the copper in the same way. For part D, you're going to look at 2 different reactions. In your lab manual, it says you're going to do the reaction between potassium iodide and lead nitrate. However, we've already looked at this reaction. So we're going to look at calcium chloride and sodium phosphate. This is what is set up in the data table at the end of your lab directions. These are both clear liquids. You need a small amount of each and just pour one into the other. The second part of D is to mix iron 3 chloride and potassium thiocyanate. You'll notice that iron 3 chloride has a color. Many transition metal compounds are actually colored, but we're going to get an interesting reaction when we mix the two of these together. You only need to add a small amount of the potassium thiocyanate to see this reaction. I'm not going to do the experiment here so that you can be surprised by what happens. This reaction is sodium hydrogen carbonate and hydrochloric acid. You'll need to pay attention to the special thing that happens with carbonates in these types of reactions. If you haven't gone over this before, make sure you look through your book or your notes to find out what exactly is going on. We're going to take the sodium hydrogen carbonate, just a small amount, and place it in the test tube.
To test the gas inside the test tube, light a splint or a match and place it in the mouth of the test tube. Observe what happens.
Our final reaction is with hydrogen peroxide, or H2O2. In your manual, it tells you that potassium iodide here is used as a catalyst, and we can show this in the chemical equation by writing the Ki over the arrow rather than with the other reactants. All we're going to do is add a small amount of the potassium iodide to the hydrogen peroxide. Any amount should give some reaction. An increased amount should make the reaction go faster. You'll notice a change in color right away, but the real reaction that you're looking for will be very subtle and will take some time to get started. So hold on to this one a second and examine it closely before you move on to the rest of your lab.